We now discuss a problem from the section Differential Equations. The problem actually a problem in coordinate geometry which will be solved through a differential equation. This question has appeared in the joint entrance examination main held on 24th June 2022 in the second shift. The problem is a particle is moving in the xy plane along a curve C passing through the point 3, 3. The tangent to the curve C at the point P meets the x-axis at Q. If the y-axis bisects the segment PQ, then C is a parabola with four options are given to us. Option A is a parabola of latus rectum 3. Option B, the length of latus rectum 6. It's a parabola. Option C, it's a parabola with focus 4 by 3, 0. Option D, it's a parabola with focus 0, 3 by 4. So we have a curve C and it is given that it is passing through 3, 3 and the tangent to that curve C at a point P meets the x-axis at Q. It is further given that y-axis bisects the line segment PQ. Then what is this curve C? So we have to show that this curve C is a parabola with one of the following properties given in options. Now that's the given problem to us. We now discuss the solution of the problem in detail. We are given the curve C and it is given that it is passing through 3, 3. Let P with coordinates x, y be any point on C. And the equation of the tangent to C at P whose coordinates are x, y is given by capital Y minus y is equal to the slope divided by dx into capital X minus x. It's given that the tangent to the curve C at the point P meets the x-axis at Q. Let's say the coordinates of Q be a, 0 for some a. Why? The tangent is meeting x-axis. So it is meeting x-axis means a point on x-axis will be some a, 0. The y coordinate will be 0 on any point on the x-axis. Now, because the tangent is passing through this a, 0, the equation of the tangent must be satisfied by a, 0. So put capital X is equal to a, capital Y is equal to 0 in the equation of the tangent. Then we get 0 minus y is equal to dy by dx into a minus x. And this will give rise to a minus x is equal to minus y into dx by dy or minus y by dy by dx. Okay, y by dy by dx. And that will give rise to a is equal to x minus y into dx by dy. It is further given that the y-axis bisects the line segment PQ, let us say at the point R at 0, b for some b. Why? Because R is a point on y-axis, therefore its x-coordinate must be 0. So that means R is the midpoint of the line segment PQ on the y-axis. And the coordinates of P, x, y, the coordinates of Q, a comma 0. So the midpoint formula you can use and equate it to 0 comma b. So that will give rise to 0 comma b, that is r, which is the midpoint of PQ, is equal to x plus a by 2 comma y plus 0 by 2 by the midpoint formula. So this will give rise to x plus a by 2 is equal to 0. That will give rise to x plus a is equal to 0. That is x plus a is x minus y into dx by dy is equal to 0. That is equal to 2x is equal to y into dx by dy. It is a differential equation which can be solved. So separating the variables and integrating, we'll get the solution. Such a method is called the variable separable method. The integral 2 dy by y is equal to dx by x integral plus log c, where c is the constant of integration. On integration, we'll get 2 log y is equal to log x plus log c. This will give rise to y square is equal to cx. Thus, we got the equation of the curve. But we have an arbitrary constant. This will be evaluated by the initial condition, that is the curve is passing through 3 comma 3. So thus the equation of the curve C is y square is equal to cx. To evaluate C, we'll use this condition that it is passing through 3 comma 3. So given that the curve C is passing through the point 3 comma 3, so put x is equal to 3, y is equal to 3 in the equation y square is equal to cx. We get 3 square is equal to 3c. That will give rise to c is equal to 3. Therefore, the equation of the curve C is y square is equal to 3x. Yes. What is this? This is of the form y square is equal to 4ax, which is the standard equation of the parabola. So therefore, this equation is the equation of a parabola. Therefore, the curve is a parabola whose length of the lattice rectum is 4a, that is the coefficient of x, that is 3. So the length of the lattice rectum of this parabola is 3. It is a parabola with the length of the lattice rectum 3. So let's look at our options. Our answer that it is a parabola with the length of lattice rectum 3 appears against option A. Therefore, our answer to this question is option A. That is the detailed discussion of the solution of the problem, which is a hybrid of coordinate geometry and differential equations. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.